Let me tell me something you know about this graph. Vertical asymptote at what one? X1, Y equal 1. X equal 1. Other facts. Give me something else. Zeros are x-intercepts at? X equal 2 and x equal negative 3. Check. I agree. Okay? Now the hard part. What else do you know about the graph? End behavior. Does it indicate horizontal or slant asymptotes? Slant. There are three ways we talked about finding the slant. All involve division. If it's strictly over x, then you can just separate and reduce. If it's dividing by a linear divisor, you could use synthetic. But if it's dividing by more power than linear, then you have to use log division. So, in this case, did you use synthetic?
Yeah.
Yes, you could use log division, by the way. It always works, but synthetic is nice. When you divide, do you know what the heck you're looking at? What is that? What does it mean?
2 minus 4.
Equals x plus 2 is the slant. This is the remainder. You could disregard it. X plus 2 is what you're interested in. So, with those, then you get graph that looks like that. Surely it's got to follow the slant asymptote, so I could sign test to verify, but I know I need to be at that slant asymptote. I don't care if it's above or below. I don't care as long as you're following it. But you definitely have to turn up to hit that x-intercept. Then what does it do? I'm probably not graphing this very smoothly. Then it's got to be positive, and what does it do until it follows the next asymptote? What's the y-intercept? What's the y-intercept? 6. Okay. So does that jive with my picture? Well, not really, but you understand. Okay. Next region. When I trip over 1, will it change signs? From positive to negative wise? Yes. What in the equation indicates you will change signs? It's to the first power. Because it's to the first power. When you're less than 1, it'll be negative. When you're more than 1, it'll be positive. So this factor will change signs, and you'll overall change signs and go negative until you get to that point. When you pass over 2, this one will change signs, and you'll start to be positive and like that. Okay, is that what?
That was like a really big line for this one.
Not big enough. There you go.
Alrighty then. Today's lesson is a lot of easy, but one little hard one at the end. So if you're going to sleep, then make sure you wake up at the end. Okay? There we go. You have talked in continuity about differentiability. We've talked about 3 reasons the derivative fails to exist. And when you say differentiable, you're saying able to differentiate or derivative exists. The 3 reasons you must commit to memory and hopefully understand why they are is lack of continuity, sharp turn, and vertical tangent. Are you with me? Perfect. Okay then, let's talk about the easiest possible problem with these, and that is just looking at a graph and saying this or that. Read the questions carefully and answer those 3 questions, and then we will go over and make corrections if necessary to those 3 questions, A, B, and C. Give them some thought, please. Excuse me. Okay. At what point is the function continuous but not differentiable? What do you say? Give me one. X equals -1. I agree 100%. Why is that? Sharp turn. Okay? Give me another.
0.
X equals 0. I agree with that. Why? Vertical tangent. Any other? Nope. Just those two. Why not 2? It says, is the function continuous but not differentiable? Is it continuous at 2? It is not. So 2 is not to be equal. Okay? At what x value or values is the function not differentiable? Just not differentiable. And so how many points do you have and what are they? -2. You agree the function's not differentiable at -2 because it's not continuous there. What else? Still -1. That's still in there. What else? 0 is still in there. And 2. Okay? Last but not least, at what point is the function differentiable but not continuous? None. That is not possible. If it's differentiable, then it must be continuous. This is a classic, famous trap question in calculus. True or false? If continuous, then must be differentiable. False. Not sharp turn, for example, is true or false? If differentiable, then continuous. True. That's true. Okay. So you'll sometimes see the question won't even say continuity. It'll just say f is differentiable at blah 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 blah. Well, within that, you assume that, and you can assume that it's also continuous, even though it doesn't say it. All right. Let's go on then to this one. Would you give this one a go? And let's talk about that. Okay. Quite that question I thought. Okay, what do you say? A, B, C, or D? A. It is A. You're talking increasing, flat. Oh, sorry, decreasing. Sorry, decreasing, flat, increasing all the way up to 3, flat at 3, increasing, flat, decreasing. The only one that fits all those is A. Which of those is the graph of f double? D. Yeah, this is the graph of f double. The slope of this is 1. Slope of this, well, it's like the derivative of x squared, so it should be linear. And then the slope of that's negative. So you get a second derivative. There. Okay. Very common issue also, and this is not difficult. It is, however, difficult to do the work that's not going to lose your points because students get lazy. So for this, focus on the work I'd like to see, please. say for a second that you had a piecewise that involved a parabola up to a point and then some kind of line. Are you with me, people? Alrighty then. I guess it would be red. The line, the parabola is what it is. It is where it is. But the line would have to be perfectly chosen so that, first of all, there was continuity. It couldn't just be any old numbers. They would have to meet for there to be continuity. And if they wanted it to be differentiable, I wouldn't also just need it to meet. I would need the derivative. There basically to be no sharp turn there. I need it to be smooth there. So I would need to match the derivative on the left so it's smoothly rolled into the linear behavior, right? The only way that's going to happen is with the perfect slope and the perfect y-intercept to move it where it needs to be. That's the question then. What do A and B have to be? Well, this is the work I would like to see. Do not give me just this is garbage. I don't want to see this. 12 equals 2A. That is meaningless, blah, blah, blah. Okay? On a multiple choice question where I'm not going to see your work, okay, maybe. But if this is homework or free response, your work should say, for continuity, the limit as x approaches 2 from the left, you could either call it f or use the branch, needs to equal the limit as x approaches 2 from the right. Needs to equal f at 2, yeah? That is the requirement for continuity. Then you can say, all right, well, the limit as x approaches 2 from below would be this function. And x approaching 2 would mean that that function would approach 12. As x approaches 2 from above, I'm looking at this function. ax plus b, as x goes to 2, approaches 2a plus b. And I think you'll agree that f is defined at 2, so it has a chance of continuity. It would be also 12, right? So this, I don't know if you need to include that again. It's my favorite one. But that's great, but it doesn't get you enough. So we also want there to be a smooth derivative transition. For differentiability, the derivative as you approach 2 from the left must equal the derivative as you approach 2 from the right. The slopes have to match on each side, so there's no sharp turn. What's the derivative of the left-hand branch at 2? Feel free to do it in 2 steps if you like. 6x add x equal 2, yeah? That needs to equal the derivative of the right-hand branch at 2. What is it? A. Well, that right there tells you that A is 12. If A is 12, then B has to be negative 12. Okay? Try one on your own, please, using appropriate work. Let's see. What'd you get for A? Which was what I found first. -1. And what then does that imply B has to be? 1. Okay. Did that go okay? Super. All right. Try this one. Also a very common problem. Just want you to see as many as I can. Get you to see. So nothing is new. Come May. Whatever it was. It'll be here before you know it. Ready? What do you say? A, B, C, or D, or E? All right. If f has a limit at 2, what must happen? For a limit to exist at a point, the left-hand and right-hand limits have to be the same. Okay? Which of these do I use for a left-hand and right-hand approach? The top one's used for both. Okay? When x is less than 2, I use that. When x is greater than 2, I use that. But surely if I'm using the same rule for both cases, it must come out the same. So A is, or 1 is, true. Is f continuous at 2? Okay, how do I get into that to investigate? Yeah, factor, remove the hole. There's a hole at 2, remove the hole. As x approaches 2, that guy wants to approach 4. That is not 1. They did not fill the hole, and so it is not continuous there. Do I even need to consider 3? Well, if it's not continuous, it cannot be differentiable. It must be 1 only. All right. Last but not least, the hard one. Okay, wake up if you're asleep. Here's the part that gets tough. Proving a sharp turn makes no derivative is harder. Not just saying, oh, Mr. Rickman told me so, so that's the way it is. Although I appreciate that blind faith. Actually, no, I resent the blind faith. You need to be able to prove a function is not differentiable. So, if you would, jot down a little picture of ye old y equals x minus 2. This is easier, this problem is easier to do, to prove that the derivative doesn't exist at 2 if you write it piecewise. Could you please tell me what is the absolute value written in a piecewise fashion? For x less than 2. Remember, they just took x minus 2 and flipped up part, right? Okay. So the part less than 2, did it get flipped or did it get left alone? Flipped. So what is the part less than 2? Negative 2, or negative x plus 2. Does that kind of jive with the equation of that piece? Negative x slope, 2y intercept? Yeah, it makes sense. What about the right-hand side, after 2? That's normal x minus 2 did not get flipped. What about 2? Do I include it or not? Remember, this is the function itself. Does the function exist at 2? It does. It needs to be included in one of the 2 places. I don't care which, but it's there. It's the derivative where it won't exist, right? Now, in a lot of problems, we then took the derivative of those pieces, but that's not the question. It says, because the show it doesn't exist using the definition of the derivative. The definition of the derivative. So by definition of the derivative, f prime at 2 is, I tend to think the alternate definition is the best for here. That's the limit as, do you remember the idea behind the alternate definition? All derivatives are about taking the slope between 2 points. It's just really different about how you call them, and then taking the 2 points closer together with a limit. In the alternate definition, you let one of the points be a concrete numerical point, in this case 2, and the other point be some varying point, x. So the slope will be f of x minus f at 2 for the rise over x minus 2 for the run. That's the slope between those 2 points. And then I get the points closer and closer together by doing what? Taking x to 2. All right, well that's great, but just like any limit, the left-hand, right-hand limits have to be the same. That's where we're going to get our proof that it doesn't exist. If I go the limit as x goes to 2 from the left, then which of those 2 functions do I use for f of x? The upper one, negative x plus 2 minus f at 2. What is f at 2? 0. Over x minus 2. Sometimes you'll have some algebra to do. This will always come out 0 over 0 on first glance, but there will always be some algebra to do. In this case, you could factor out a negative, then cancel. What do you get? Negative 1, right? Tell me why visually that makes sense, or that verifies what we see. Yeah, the slope on this side is negative 1. No matter what you do to x, taking it closer and closer, the slope still approaches negative 1. So, okay? However, if you take an x on the right side of 2, like over here, and find the slope, what do they approach? Well, on the right side of 2, which function do I use? It's minus 2. Minus f at 2, which is still 0, over x minus 2. Well, that reduces to straight up positive 1. Now, because these are not the same, negative 1 is not equal to positive 1, the limit, which is the derivative, cannot exist. That's why it has to be smooth there, because that's the only way the left hand, right hand, the limits will be the same. All right. Would you try, these are hard, you need to practice them, so try that one. Notice it first asks you to demonstrate continuity, then show not differentiability. So you should have 2 pieces to this. Continuous, yes, but differentiability, no. Keep in mind you should always be using G in this problem, not F. I almost used F. How are we? Okay, did the continuity work something like that? They both have a value of 18. Yes? Okay. For the left-hand slopes, g of x would be x squared plus 2. G at 4 we found over here is 18. X minus 4. Those slopes factor into x squared minus 16, so x plus 4, x minus 4. The left-hand slopes seem like they're approaching 8. As you approach from the right, though, I'm using a different function, 4x plus 2. Four x minus 16 would factor into 4 times x minus 4. The x minus 4 drops away, and that limit is 4. Those are not equal. So G prime at 4 does not exist. Okay? How'd that go? Great. Okay. Yep.
You have to use the definition of the derivative view when it doesn't ask for it.
I feel like it did, but you've read this differently?
Yeah, I just read the derivative.
Like f prime this side. They will say definition of the derivative. Generally, if it's a free response question, and you want to show it's not differentiable, you have to use it. Okay? Okay. Answers to last night's homework. Hopefully it went well. Here are my answers, and then we'll go back over questions if you have them. Number uno. 2 pi over 15. Can I get a whoop whoop? Whoop whoop. That was definitely the lamest whoop whoop I ever heard. Pi over 6. Number 2. Number 3 was 256 pi over 5. I would bet many of you said 128 pi over 5. You inferred that they wanted the right side of the graph only. They didn't say that. It's from -2 to 2, not 0 to 2. Okay? 4 was 8 pi. All right. You could use symmetry on this 3, by the way. So if you did 0 to 2, then you could just stick a 2 down in front all the way down and call it good. Number, what the cockadoodie is that? Let's see. Number 5, I suppose. It's not numbered, but you understand the pattern. After 4 comes 5. 4.7698. 4.7698. You didn't have to give me 4, so if you gave me 770 or 769, both are acceptable. For the next one, 8.2635. And for the last one on that page, it was root 3 pi.
We asked for
The equation.
it says is given by, so we only had to set up the integral for that one.
Where?
For the one that is 8 point stuff, it only asks
Oh.
for 8.
Oh, I see. I stripped out the multiple choices.
I mean, I guess I can say
Gotcha. So you're right. Pi 0 to 1, 1 plus sine of pi x squared minus x squared squared. That's the integral. I guess you're right. Okay. Oh, yeah. I can read my own writing. Yes, x to the third. Yes. Okay. For the first one, finding a slant by just separating the fractions and reducing. I have y equals x plus 1 and y equals 3x plus 2. Just separate the fractions and reduce if it's just over x. If you're dividing by a linear factor or only one factor, you can use synthetic. Y equals x plus 3, 3x minus 7, and x minus 1. If you're dividing by more than linear, then you should use long division. Y equals x, y equals 3x, and y equals 4x minus 4. And I'm just giving you the graphs here, although I'm happy to talk about the asymptotes in the last, second to last row. The end behavior here was y equals 1/2. This one had end behavior y equals x minus 2. This one was y equals 2x. This was the x-axis, or y equals 0. And this one was, what was it? Y equals x. What was it? X? Just x, yeah? Okay. Let me know what questions you have. You want to go over anything you did not get, or get made a mistake? Which one? E, yes. Any others want to think about it, or just move? A? Maybe which one? D? D's asymptote? Because the D didn't have the graph, right? Okay. Okay. Cool. Shall we just start from scratch and talk thought process as I went? Okay. So, let's walk through this. The first thing I would do is factor. If it's not already factored, it's factored. Boom. I would then look for holes as evidenced by common factors. There are none in this case. I would then say the top zeros are the x-intercepts. The x-intercept is only 0. X squared plus 1 has no real zeros, so I have a point at the x-axis, at the origin. The vertical asymptotes are where the denominator is 0, x equals plus or minus 2. So that is getting me there. Now I talk end behavior. I would love it if you could just look at this and see you're going to have a slant asymptote. You would do that by saying, roughly it's x cubed over x squared-ish. That's x-ish. It's a linear asymptote. We're going to need to divide to find it. Because it's not a single factor, I need to long divide it. So I'm going to divide x squared minus or plus no x minus 4 placeholders into x cubed plus no x squareds plus x plus 0 constant. Placeholders help keep everything straight. X squared into x cubed. How many times does x squared go into x cubed? 1x times, or just x. If I multiply, I get x cubed plus 0x squared minus 4x. I change signs, so I change every one of these signs, and then I add no x cubes, no x squareds, and I get, what, 5x. 5x, though, x squared doesn't go into 5x, and so that must be the remainder, yeah? As x gets large, the remainder goes to 0, and so your graph starts to approach just the stuff without the remainder. That's how we see that y equals x is the slant asymptote. Our graph will approach behaving like y equals x as x gets really large. So think of it on the outside. It's really only a guide for the outside. Okay, in this quadrant over here, by sign test, you could see that it has to be negative. It can't be then up here, because then it would stay negative, and it would get an x-intercept where you know you don't have it. So as far as where it is, the graph must be down here. I could sign test again between -2 and 0. But you could bypass that by saying, well, when I jump over -2, that factor is to the first, so before it'd be negative, but after it'd be positive, and therefore I'm going to have a sign change back to -2. So instead of being negative, now I'm going to be positive. You could use that same kind of thinking about what's going to happen at 0. Before 0, x would be negative, but after 0, positive, so we're getting a sign change there. And after 2, there's a sign change. So the graph, okay? Okay, and then A. We still have a question on A. Okie dokie. A's kind of got the wacky occurrence of a hole with an x-intercept. That is kind of funky. I did start by marking the hole, and then removing it to make my life easier. So that was my first step. To find where the hole is, the y of the hole, you then put 0 into what's left after. Well, I still have an x there, so I'm still going to get a 0 there. I have a hole at the origin. I have x-intercepts at 1, an x-intercept at 1, a vertical asymptote at -3. Then the end behavior. As x goes to infinity, I have equal power top and bottom. So x squared over 2x squared, y would approach 1/2 as x gets large. So I have a vertical asymptote at 1/2. I'm going to change my scale a little so it's easier to locate. Who? The x scale is still 1, by the way, so it's not too confused. And then graph. Well, sign test would say positive here. It can't therefore be down here because that would mean an x-intercept of negative. This must be up here. After 3, -3, that would stay the same sign. Because that's squared, there would be no sign change around -3. So if y was positive before, it'll be positive after. Now don't worry about that horizontal asymptote in there because really it's just a guide for as x goes to infinity. So if it helps you to just erase the middle part where it's applicable, then go ahead. It is okay to go over that. Between 0 and 1, I will sign change here, and so I'll start to be negative. But after 1, I will change back to positive, and that would allow me to follow my horizontal asymptote. That's it. Cool. And D. D. Is D still a question? Remember, all these asymptote questions amount to end behavior. End behavior amounts to infinite limits. And so if I take the infinite limit of this, because there's more power in the denominator, the fractions would get closer and closer to 0. That implies that y goes to 0, so y equals 0 is a horizontal asymptote. And the same is true for negative. Okay? By the way, I don't want you to fall into the temptation that the horizontal asymptote necessarily has to be on both sides. There are cases where you have a horizontal asymptote here on the positive side, but there on the negative side. That can happen. That's a thing. All right, any other questions? Super. Well, you got time to work on tonight's homework. And that's all she wrote.
Can I see 2 answers?
Sure.